The Earth is an active planet. Volcanic eruptions, erosion, continental shifts, and meteoric assaults constantly rework the planet's surface. $4.6 billion years ago, the Earth was a lifeless boil of hot magma. Meteorites striking the planet brought rocks and more energy, raising the surface temperature to 1,800 degrees Fahrenheit. The meteoric iron pulled to the Earth's center by gravity helped build the iron core, surrounded by the molten mantle. The unstable crust broke into huge plates thousands of miles wide. A trip to Western Australia helps identify some of the oldest land masses on Earth. These bits and pieces of ancient crust are unlikely survivors of a cycle of formation and destruction. The vertical stripes date back some 3.8 billion years, marking the time the Earth began to cool and oceans began to form. No one knows exactly how inanimate compounds became the earliest forms of life, but it happened at about this time, it happened in the sea, and it changed the history of Earth. In an effort to understand what early life might have looked like, scientists like Princeton microbiologist Telis Onstadt study certain living organisms. Extremophiles are unusual colonies of bacteria that thrive in the same sort of extreme conditions that may have existed 3 billion years ago. Onstadt digs 200 feet below the surface to find them.
Now these are living bacteria, and they live at temperatures approaching the boiling point of water. They live at pressures that are 100 times the atmosphere. They live in a salty, briny solution that's alkaline and contains gases that are toxic to us, and yet they still manage to survive.
Extremophiles could have survived on Earth with no oxygen, but no other organisms could. So how did the oxygen-loving creatures that dominate the planet today arrive? The red sedimentary rocks in Australia's Karenjini offer clues. The red comes from iron oxide, formed when dissolved iron in the ocean combined with oxygen and formed a compound most familiar to us as rust. The huge amount of iron oxide here leaves little doubt that living organisms in the ocean were excreting oxygen. Enough of these bacteria were at work to fill the atmosphere over time with oxygen as a byproduct of their photosynthesis. With an atmosphere full of oxygen and an ozone layer screening out harmful ultraviolet light from the sun, the land became as hospitable as the ocean. After eons, life existed in both environments. Life arose early in our planet's history, and today, Earth is the only planet in our solar system capable of supporting it as we know it. Geologic forces build and destroy the staging areas, but life reacts and carries on.